In the summer of 1952, something extraordinary happened in the middle of the North Atlantic Ocean. A sleek American ship, her hull painted a distinctive red, white, and blue, carved through the waves at a speed no passenger vessel had ever achieved before or has achieved since. The SS United States was making her maiden voyage, and in doing so, she was about to shatter every speed record on the world's most prestigious maritime route. The Atlantic crossing had always been more than transportation. For centuries, it represented power, prestige, and national capability. Britain's great liners, the Mauretania, the Queen Mary, the Queen Elizabeth, had dominated this ocean highway, carrying immigrants westward and the wealthy in both directions, their size and speed serving as floating advertisements for British engineering and imperial reach. Germany had challenged this supremacy before both world wars with vessels like the Kaiser Wilhelm der Grosse and the Bremen. France contributed the elegant Normandy. But America, the nation that had emerged from World War II as the world's unquestioned industrial superpower, had never held the ultimate prize, the blue riband, the unofficial trophy awarded to the fastest Atlantic crossing. It changed on July 7, 1952, when the SS United States arrived at Bishop Rock Lighthouse off the southwestern tip of England, having crossed from Ambrose Light at New York in 3 days, 10 hours and 40 minutes, an average speed of 35.59 knots eastbound. On her return voyage, she was even faster, 3 days, 12 hours and 12 minutes, averaging 34.51 knots westbound against prevailing winds and currents. These weren't marginal improvements over existing records. The United States demolished them, beating the previous holder, Britain's Queen Mary, by 10 hours. In nautical terms, this was less a victory than an annihilation. But the SS United States was never simply a passenger liner engaged in commercial competition. She was something far more complex, a weapon designed to look like a luxury hotel, a military transport disguised as a civilian vessel, a Cold War statement rendered in aluminum and steel. Her true purpose was known only to a select few in the Pentagon and the Department of Defense. Her construction plans, her powerplant specifications, her propeller design, all were classified at levels typically reserved for warships. Even her designer, the obsessive naval architect William Francis Gibbs, was forbidden from revealing certain aspects of his own creation. This paradox defined everything about the ship. She was built to carry passengers across the Atlantic in supreme comfort, yet her interiors were austere by European standards, sacrificing ornate luxury for practical American efficiency. She was designed to be profitable in peacetime commerce, yet her operating costs were so high that she could never truly pay her way. She was created to be the fastest thing afloat, and she achieved that goal so completely that her record has stood unchallenged for over 7 decades. Yet this very speed made her expensive to operate and maintain. The SS United States was commissioned during a unique moment in American history. The nation had won the most devastating war in human history and now found itself in an ideological struggle with the Soviet Union that demanded constant demonstrations of technological and industrial superiority. The Berlin airlift had just concluded. The Korean War was raging. The possibility of a Third World War, fought with nuclear weapons, seemed terrifyingly plausible. In this context, building the world's fastest ship was more than commercial ambition. It was strategic necessity wrapped in national pride. Yet for all her military purpose and Cold War symbolism, the United States was also genuinely beautiful. Her hull, designed with a knife-edge bow and graceful shear, cut through water with minimal resistance. Her superstructure, built almost entirely of aluminum to save weight, rose in clean, modern lines that spoke of speed even when she was stationary. Her 2 massive funnels, raked at a dramatic angle, announced her presence in any harbor. She looked fast, and she was fast, the perfect marriage of form and function. Today, more than 70 years after her triumphant maiden voyage, the SS United States lies deteriorating at a Philadelphia pier, her future uncertain, her condition precarious. The fastest ocean liner ever built has become one of the world's most endangered historic vessels. Her story, from conception to construction, from glory to abandonment, from record-breaking achievement to preservation crisis, illuminates not just maritime history, but the broader American experience of the 20th century. The heights of engineering ambition, the complexities of military-civilian integration, the harsh economics of technological supremacy, and the difficulty of preserving achievements once their immediate utility has passed. This is the story of that ship, the man who created her, the era that demanded her, and the legacy she left behind. To understand the SS United States, one must first understand William Francis Gibbs, because the ship was, in every meaningful sense, an extension of his personality, his obsessions, and his vision of what American engineering could achieve. Born in Philadelphia in 1886 to a prosperous family, Gibbs developed an early fascination with ships that would shape his entire life. As a boy, he built ship models with meticulous attention to detail. As a young man, he studied economics at Harvard. His father, a prominent lawyer, considered engineering beneath the family's social station, but Gibbs's heart remained with naval architecture. He taught himself the discipline through intensive study, poring over technical journals, visiting shipyards, and corresponding with practicing naval architects. His brother Frederick Herbert Gibbs shared his passion, and together they established Gibbs Brothers, Inc., a naval architecture and marine engineering firm, in 1922. William Francis Gibbs lacked formal engineering credentials, but what he lacked in pedigree he compensated for with fierce intelligence, relentless work ethic, and an almost pathological attention to detail. He would become, arguably, the most important American naval architect of the 20th century, designing hundreds of vessels from cargo ships to destroyers. But throughout his career, one dream obsessed him above all others: creating the world's greatest passenger liner, flying the American flag. Gibbs's opportunity came in the 1930s when he was hired to complete the conversion of the German liner Vaterland, which had been seized during World War I and renamed the Leviathan. Working on this enormous vessel gave Gibbs intimate knowledge of large passenger ship design, but it also frustrated him. The Leviathan was slow, expensive to operate, and ultimately unsuccessful. Gibbs became convinced he could do better, much better. What set Gibbs apart from his European contemporaries was his philosophy of ship design. While British and French naval architects created floating palaces filled with wood paneling, elaborate metalwork, and luxurious fabrics, Gibbs was obsessed with three principles: speed, safety, and structural efficiency. He believed most ships were dangerously vulnerable to fire, noting that the luxury materials that made European liners so elegant were also highly combustible. He had studied the catastrophic 1934 fire aboard the Morro Castle, which killed 137 people, and the blaze that destroyed the French liner Normandy while she was being converted to a troopship during World War II. These disasters convinced Gibbs that passenger ships needed to be fundamentally reconceived. His solution was radical: eliminate wood entirely. The SS United States would be constructed of metal throughout, primarily steel and aluminum. There would be no wooden furniture, no wooden paneling, no wooden decking. Even the Steinway pianos aboard would have aluminum frames. The butcher's carving boards would be synthetic. The crew's shoes had metal taps instead of wooden heels. This obsessive pursuit of fireproofing became legendary. Gibbs once remarked that the only wood aboard the United States was in the butcher's chopping blocks, and he wasn't entirely happy about that. But fire safety was only part of Gibbs's vision. He was equally focused on speed, and he understood that speed required power and power required reducing weight. Here, his decision to build the superstructure from aluminum served dual purposes. Aluminum weighs roughly 1/3 as much as steel, so by using it extensively above the waterline, Gibbs dramatically improved the ship's power-to-weight ratio, while simultaneously lowering the center of gravity, enhancing stability. This wasn't merely innovative, it was revolutionary. No ship of the United States size had ever incorporated so much aluminum into its structure. Gibbs's personal life became entirely subsumed by his work. He never married, maintained few friendships outside professional relationships, and worked constantly. His office in New York became a command center where he exercised authoritarian control over every aspect of his designs. He was known for his volcanic temper and his refusal to tolerate what he considered incompetence or laziness. He could quote technical specifications from memory and expected everyone who worked for him to demonstrate similar mastery of detail. During World War II, Gibbs's firm designed military transports and cargo vessels, including the Liberty ships that carried American supplies across the Atlantic. But throughout the war, he never abandoned his dream of a superliner. He understood that such a ship would need government support. Passenger liners were too expensive for private companies to finance alone. He also recognized that the post-war period, with its anticipated competition with the Soviet Union, might create the political will to fund such a project if it could be justified on military grounds. Gibbs was not primarily motivated by profit. He was motivated by vision, to prove that American engineering could surpass European maritime traditions, to create a ship so fast and so well designed that she would dominate the North Atlantic for generations, and to build a vessel that could serve the nation in both peace and war. The SS United States would be his masterpiece, the culmination of everything he had learned across decades of study and practice. In 1946, as America transitioned from wartime to peacetime economy, Gibbs began lobbying in Washington for support to build his dream ship. He found receptive audiences in the Navy and among lawmakers who understood that the Cold War would be fought through demonstrations of technological superiority as much as through conventional military strength. The ship Gibbs proposed would not be merely fast, it would be the fastest. It would not be merely capable of military conversion, it would be designed from the keel up with that conversion in mind, able to carry 14,000 troops with minimal modification. And it would be American, built by American workers, powered by American engines, crewed by American seamen, a floating testament to American capability. In 1948, his persistence paid off. The United States Maritime Commission and the Department of Defense agreed to heavily subsidize construction of the vessel, which would be operated by the United States lines but would remain, in essence, a national asset, available for immediate military requisition in case of emergency. William Francis Gibbs was 72 years old when construction began. He would see his life's dream realized. On February 8, 1950, the keel of the SS United States was laid at the Newport News Shipbuilding and Drydock Company in Virginia, one of America's premier shipyards and the birthplace of many of the nation's greatest vessels. From the beginning, this was no ordinary construction project. Security was tight. Certain areas of the shipyard were restricted even to workers without special clearance. Blueprints for critical systems were kept locked away. And hovering over the entire enterprise was William Francis Gibbs, making the 300-mile journey from New York to Newport News so frequently that he kept a small apartment near the yard. The ship taking shape on the ways was massive, 990 feet in length, just over 101 feet in beam, designed to displace 53,330 gross tons. But these dimensions, impressive as they were, told only part of the story. What made the United States extraordinary was what couldn't be easily measured or photographed. The classified propulsion system, the innovative structural techniques, the military features disguised as civilian amenities. At the heart of the ship were 8 Foster Wheeler boilers, the most powerful marine boilers ever installed in a commercial vessel, feeding 4 Westinghouse-geared turbines. The engineering plant could generate approximately 240,000 shaft horsepower, though the exact figure remains classified to this day. This power output was extraordinary. For comparison, the Queen Mary, previously the fastest liner on the Atlantic, developed about 160,000 shaft horsepower. The United States would have 50% more power than her British rival while weighing less. The result would be speed unprecedented in maritime history. But the propulsion system was classified not just because of its power, but because of its military applications. The turbines, boilers, and reduction gears were designed to naval specifications, with redundancy and damage resistance features typical of warships. The machinery spaces were compartmentalized so that damage to one section wouldn't disable the entire plant. The engines could operate at sustained high speeds for extended periods, critical for outrunning submarines or other threats. Everything about the power plant was designed with the assumption that this ship might someday have to cross the Atlantic while under attack. The hull design was equally sophisticated. Gibbs employed a bulbous bow, a protruding section below the waterline that reduced wave-making resistance at high speeds. This feature, common on modern ships, was still relatively novel on passenger liners in the early 1950s. The hull form was tested extensively in the Model Basin at the Stevens Institute of Technology in New Jersey, where scale models were towed through water at speeds equivalent to what the full-size ship would achieve. Engineers measured resistance, analyzed wave patterns, and refined the shape until they achieved optimal hydrodynamic efficiency. The propellers themselves were classified. To this day, no clear photographs of the United States propeller configuration have been released. What is known is that she had 4 propellers of advanced design, each one crafted to extract maximum thrust from the enormous power being generated by the turbines. The propeller shafts, each weighing several tons, were installed with tolerances measured in thousandths of an inch. The precision required was extraordinary, and the workers at Newport News, many of whom had built warships during World War II, rose to the challenge. Above the waterline, the superstructure presented different engineering challenges. Gibbs's decision to use aluminum extensively meant that conventional shipbuilding techniques had to be adapted. Aluminum and steel have different properties, different thermal expansion rates, different welding requirements, different structural behaviors. Joining aluminum superstructure to steel hull required careful engineering to prevent galvanic corrosion and maintain structural integrity. The shipyard workers had to learn new techniques, and Gibbs's team developed innovative solutions to problems that had never been encountered before at this scale. The aluminum superstructure reduced the ship's weight by approximately 2,500 tons compared to equivalent steel construction. This weight savings improved stability, reduced draft, and contributed to the ship's extraordinary speed. But it also created challenges in interior design. Aluminum is softer than steel, which complicated the installation of heavy machinery and required reinforcement in certain areas. Nevertheless, Gibbs considered the trade-off worthwhile. Fire safety, Gibbs's particular obsession, influenced every design decision. The ship was divided into multiple fire zones, each separated by fire-resistant barriers. Sprinkler systems were installed throughout. Smoke detectors, a relatively new technology in the early 1950s, were positioned in critical areas. Doors were designed to seal automatically in case of fire. Even the paint used on bulkheads and decks was selected for fire resistance. Gibbs decreed that the ship would be, as he put it, nearly fireproof, an audacious claim that her subsequent service record would largely vindicate. The military conversion capability was designed into the structure from the beginning. The ship could be converted to carry approximately 14,000 troops in 48 hours. The luxurious first-class staterooms could be fitted with standee bunks. The swimming pools could be drained and covered. The public rooms could be converted to berthing areas. Medical facilities could be expanded. The galleys could be reconfigured for mass feeding rather than restaurant service. All of this was planned in advance, with the necessary equipment stored and the procedures documented. As construction progressed through 1950 and into 1951, the ship began to take visible shape. Her distinctive two-funnel silhouette emerged. The funnels raked back at an aggressive angle that suggested motion even when the ship was stationary. Her bow, sharp and purposeful, declared her intended use. Her hull, painted in traditional ocean liner colors, black below the waterline, white above, concealed the innovations within. On June 23, 1951, the SS United States was launched. Eleanor Roosevelt, widow of President Franklin D. Roosevelt, served as sponsor, christening the ship before a crowd of thousands. The vessel slid down the ways and into the James River, displacing an enormous volume of water as she touched her element for the first time. Fitting out, the process of installing machinery, furnishings, and equipment would continue for another year. William Francis Gibbs, watching from the stands as his creation entered the water, permitted himself a rare moment of satisfaction. But he knew the real test was yet to come. The ship had been built. Now she had to prove she could do what she was designed to do, become the fastest passenger vessel in the world. By late spring 1952, the SS United States was ready. Trials in the Atlantic had demonstrated her astonishing capabilities to the Navy observers aboard, though the exact speeds achieved during those trials remained classified. What was clear was that William Francis Gibbs's obsessive engineering had produced something extraordinary. The ship vibrated less than any large vessel of her era. Her maneuverability was exceptional for her size. And she was fast, dramatically, spectacularly fast. On July 3, 1952, the United States departed New York on her maiden voyage to Southampton, carrying 1,660 passengers, many of them dignitaries, journalists, and maritime officials invited specifically to witness what was expected to be a record-breaking crossing. Among the passengers were Marine Corps Commandant General Lemuel Shepard, Secretary of the Navy Dan Kimball, and representatives from various European shipping lines, invited to observe American maritime prowess firsthand. Captain Harry Manning commanded the ship. Manning was an experienced mariner, holder of a Medal of Honor for his role in rescuing 32 men from a sinking ship during a typhoon years earlier. But even Manning, for all his experience, had never commanded anything remotely like the United States. The ship responded to helm commands with the precision of a destroyer. Her massive engines, generating their classified but enormous power, drove her through the Atlantic swells at speeds that seemed impossible for something weighing over 50,000 tons. The crossing itself was uneventful in terms of weather or incident, which allowed the ship to demonstrate her true capabilities. Hour after hour, the United States maintained speeds well over 30 knots, faster than most warships of the era could sustain. In the engine rooms, the Westinghouse turbines spun at incredible velocities, their precision bearings holding tolerances that prevented destructive vibration. The Foster Wheeler boilers consumed fuel oil at prodigious rates, converting it into superheated steam that drove the turbines. The entire engineering plant operated in a coordinated symphony of mechanical precision that represented the pinnacle of marine engineering. Above, in the passenger spaces, people marveled at the smoothness of the ride. High speed in rough seas typically means violent motion, but the United States hull form and stabilization systems minimized pitching and rolling. Passengers could walk the decks, dine in the restaurants, and sleep in their cabins without the excessive motion that characterized many fast Atlantic crossings. This was intentional. Gibbs understood that commercial success required not just speed but comfort, and he had designed the ship to deliver both. On July 7, after 3 days, 10 hours, and 40 minutes at sea, the United States passed Bishop Rock Lighthouse, the traditional measuring point for Atlantic crossings. She had averaged 35.59 knots eastbound, beating the Queen Mary's record by approximately 10 hours, an enormous margin in an era when records were typically broken by minutes. When the official time was announced, celebrations erupted aboard the ship. The crew, American merchant mariners who had spent years watching European ships dominate the Atlantic, felt vindicated. William Francis Gibbs, who had traveled aboard for the maiden voyage, allowed himself the briefest of smiles before immediately focusing on the return crossing. The westbound passage, traditionally slower because ships face prevailing winds and currents, was even more impressive. Despite these natural impediments, the United States made the crossing in 3 days, 12 hours, and 12 minutes, averaging 34.51 knots. In both directions, she had obliterated existing records. The blue-ribboned, that unofficial but prestigious trophy representing supremacy on the North Atlantic, now belonged to America. The media coverage was euphoric. Headlines proclaimed American maritime supremacy. Newsreels showed the ship arriving in Southampton and New York to enthusiastic crowds. Magazine articles detailed her technical specifications, at least those that weren't classified, and celebrated American engineering prowess. In the context of 1952, with the Korean War ongoing and Cold War tensions high, the United States' achievement resonated beyond maritime circles. This was proof, visible and dramatic, that American technology surpassed Soviet capabilities and rivaled anything Europe could produce. But beneath the celebration, experienced maritime observers understood that the ship represented a peculiar achievement. She had won the speed trophy decisively, but at what cost? The fuel consumption necessary to maintain such speeds was staggering. The machinery required to generate 240,000 shaft horsepower was complex and required highly skilled maintenance. The crew of approximately 900 was larger and more expensive than those of comparable European ships, because American maritime unions had negotiated strong contracts that ensured good wages but increased operating costs. The United States Lines, the company operating the ship, faced a fundamental economic paradox. They possessed the fastest ship on the Atlantic, which was excellent for prestige and marketing, but speed by itself didn't guarantee profitability. The ship could make more round trips per year than slower vessels, which theoretically meant more revenue. However, her operating costs were so high, fuel, crew, maintenance, that even with good passenger loads, the economic model was questionable. Only the substantial government subsidies, justified by the ship's military value, made the operation financially viable. William Francis Gibbs understood this tension, but believed he had built the ship correctly. Speed was not merely a competitive advantage, it was strategic value. In case of war, the United States could cross the Atlantic faster than submarines could effectively intercept her. She could deliver thousands of troops to Europe while exposed to minimal risk. This capability, built into her fundamental design, justified the costs in Gibbs's engineering worldview. The fact that such capabilities made commercial operation difficult was secondary to the larger strategic purpose. Yet for passengers in the summer of 1952, such economic and strategic considerations were distant concerns. What mattered was the experience of traveling aboard the world's fastest ship, of crossing the Atlantic in unprecedented time, of being part of a technological achievement that seemed to herald a new era of American maritime dominance. That era would prove shorter than anyone imagined, but for a few shining years in the 1950s, the SS United States represented everything America wanted to believe about itself: that it could out-engineer, outbuild, and outperform any rival, and that American innovation would continue to push the boundaries of what was possible. The SS United States offered a distinct vision of transatlantic luxury, one that differed significantly from her European rivals in philosophy and execution. While ships like the Queen Mary, the Queen Elizabeth, and the French line's Isle de France embraced elaborate ornamentation, rich wood paneling, and traditional maritime elegance, the United States presented something different: modern American efficiency married to understated sophistication. This aesthetic was not accidental. It reflected both William Francis Gibbs's engineering priorities and a conscious choice by the ship's designers to create something distinctively American rather than imitate European tradition. The result was a ship that, to some passengers, seemed almost austere compared to the opulence they expected from luxury liners, while to others it represented refreshing modernity and practical good taste. The first-class public spaces demonstrated this approach. The grand ballroom, located on the promenade deck, was spacious and elegant, but relied on clean lines and subtle decoration rather than ornate gilt and crystal. The lighting was modern, utilizing the latest fluorescent and incandescent technology to create ambience without the elaborate chandeliers characteristic of European ships. Furniture was contemporary in style, designed by noted American designers who favored function as much as form. The color schemes tended toward neutrals, grays, tans, whites, accented with blues and reds that echoed the ship's painted hull. The first-class dining room could seat 676 passengers and stretched nearly the full width of the ship. Unlike some European liners with 2 or even 3 separate first-class dining salons, the United States concentrated her first-class passengers in a single large space. The room featured murals by Louis Boucher depicting various American subjects, but the overall effect was restrained compared to the elaborate decorative schemes aboard ships like the Normandy. Critics noted that the room was handsome but not ostentatious, impressive but not overwhelming. First-class staterooms continued this philosophy of practical luxury. The accommodations were comfortable, with private bathrooms in nearly all first-class cabins, still a relative luxury on many ships of this era. The furnishings were well made but modern and simple. There was no elaborate wood carving, no Baroque ornamentation. Everything was designed for comfort and utility. The ship offered various categories of first-class accommodations, from standard staterooms to elaborate suites, but even the suites maintained the overall design aesthetic of restrained elegance. The absence of wood created interesting design challenges. Where European ships would have used mahogany, teak, or oak paneling, the United States employed aluminum panels with various finishes, formica laminates, and other synthetic materials. These choices supported Gibbs's fire safety objectives, but required designers to think creatively about color and texture. The result was a ship that felt, in some ways, more like a high-quality modern hotel than a traditional ocean liner, which was, in many respects, exactly what the designers intended. The ship's public spaces included multiple lounges, smoking rooms, writing rooms, libraries, and observation areas. The Navajo Lounge, decorated with Southwestern American motifs, was particularly distinctive, offering passengers a uniquely American-themed space rather than the European or generic nautical themes common on other ships. The theater could show motion pictures or stage live entertainment. The gymnasium offered modern exercise equipment. The outdoor pool, located aft on the sun deck, was among the ship's most popular features, particularly during summer crossings. Cabin-class passengers, occupying the middle tier of the ship's three-class configuration, experienced a similar design philosophy on a more modest scale. Their accommodations were comfortable, if not luxurious, their public rooms attractive, if not elaborate. The ship's design reflected traditional class distinctions of transatlantic travel while ensuring that even cabin-class passengers traveled in reasonable comfort. Tourist-class passengers, primarily immigrants and budget-conscious travelers, occupied the forward and lower sections of the ship. Their accommodations were basic but clean and well-maintained, far superior to the steerage conditions that had prevailed on immigrant ships of earlier eras. Even at this lowest fare level, passengers benefited from the ship's modern design, stability, and speed. The crew of approximately 900 was entirely American, a point of national pride, but also a source of operational challenge. European liners typically employed mixed nationality crews, often with Italian or British officers and staff from various countries, taking advantage of lower wage scales outside the United States. The United States lines employed American merchant mariners throughout, which meant higher labor costs, but also ensured that crew members could be called up for military service if the ship were requisitioned, maintaining the vessel's dual civilian-military purpose. The food service reflected American abundance. The ship's galleys could prepare thousands of meals per day, and the menus offered extensive choices. Unlike some European ships, where French cuisine dominated even for non-French passengers, the United States dining rooms served recognizable American and international dishes prepared to high standards, but without excessive culinary pretension. The wine lists were extensive, the service professional, but the overall approach was more democratic than some European ships, where rigid formality still governed first-class dining. Celebrity passengers became regular features of the ship's voyages. In the 1950s, before jet aircraft became dominant, prominent people crossing the Atlantic had few alternatives, and many chose the United States for its speed and modern amenities. The passenger lists over the years included Duke Ellington, Harry Truman, Walter Winchell, Cary Grant, John Wayne, Marlon Brando, and countless other entertainers, politicians, business leaders, and social figures. The ship became known as a celebrity vessel, and the presence of famous passengers generated media attention that served as valuable marketing. Yet for all its modernity and speed, the SS United States never quite captured the public imagination in the way that some of her European rivals did. The Queen Mary became an icon, her size and traditional luxury creating a legendary reputation. The Isle de France was celebrated for her French elegance. The Andrea Doria, despite her tragic sinking, was mourned as a masterpiece of Italian design. The United States, by contrast, was respected, admired for her technical achievement, but perhaps not quite loved in the same visceral way. This may have reflected the ship's essential character. She was designed by an engineer who prioritized function over form, speed over spectacle, practical safety over aesthetic risk. The result was a vessel that was, in many ways, the most advanced passenger ship ever built, but one that lacked the romantic mystique of slower, more ornately decorated rivals. She was fundamentally a very American creation, efficient, modern, powerful, and practical, but perhaps lacking the old-world glamour that many passengers still associated with transatlantic travel. The years from 1952 through the early 1960s represented the United States' golden era. She maintained her regular schedule, departing New York every 2 weeks for Southampton and Le Havre, crossing at speeds other ships couldn't match, delivering passengers to Europe nearly a day faster than any alternative. For business people who valued time, for travelers who enjoyed the prestige of the world's fastest ship, for Americans who took pride in national achievement, the United States was the obvious choice. But even during these successful years, the future was being written. Across the Atlantic, at various European airports, jet aircraft were beginning to carry passengers. The journey took mere hours rather than days. The fares, initially expensive, would eventually become competitive with ship travel. The convenience was undeniable. The handwriting, for those who cared to read it, was on the wall. To truly appreciate the SS United States, one must understand the engineering revolution contained within her hull. This was not merely a fast ship. It was a demonstration of engineering principles pushed to their theoretical and practical limits, a synthesis of naval architecture, mechanical engineering, and metallurgical science that represented the state of the art in the early 1950s and in many respects has never been surpassed. At the foundation of the ship's capabilities was her power plant, the most potent marine propulsion system ever installed in a passenger vessel. The 8 Foster Wheeler boilers, arranged in 4 separate fire rooms, generated superheated steam at pressures of approximately 925 pounds per square inch and temperatures reaching 975 degrees Fahrenheit, specifications more typical of naval destroyers than civilian liners. These conditions allowed for exceptional thermal efficiency and maximum power extraction from the fuel oil being consumed at rates approaching 1 ton per nautical mile at top speed. The steam from these boilers fed 4 Westinghouse-geared turbines, each one a masterpiece of precision engineering. High-pressure steam entered each turbine at supersonic velocity, expanding through multiple stages of carefully shaped blades that extracted energy with remarkable efficiency. The turbines spun at thousands of revolutions per minute, their rotational energy then transmitted through reduction gears that converted high-speed, low-torque rotation into the lower-speed, high-torque output needed to turn the massive propeller shafts. These reduction gears themselves represented significant engineering achievements. Each gear set contained teeth machined to tolerances measured in 10,000ths of an inch, lubricated by pressurized oil systems that prevented metal-to-metal contact even under the enormous loads being transmitted. The gear teeth were manufactured using advanced metallurgical processes and hardened to resist wear during the millions of rotational cycles they would experience during the ship's service life. The compartmentalization of the machinery spaces followed naval practice. The 4 engine rooms and 4 fire rooms were separated by watertight bulkheads, ensuring that flooding or damage to one compartment wouldn't compromise the entire propulsion plant. Each turbine could theoretically operate independently, providing redundancy and damage resistance. This arrangement was mandated by the ship's dual-purpose design. In military service, she might need to operate with battle damage, continuing at reduced but still substantial speed even after suffering hits that would cripple civilian vessels with less compartmentalized designs. The propellers, those classified marvels whose exact configuration remains secret, were designed to operate efficiently at speeds that created significant cavitation, the formation of vapor bubbles in the water due to extreme low-pressure conditions on the blade surfaces. Cavitation, if not properly managed, causes erosion damage, vibration, and efficiency losses. The propeller designers addressed these challenges through blade shape, pitch distribution, and material selection. The propellers were reportedly manufactured from manganese bronze alloy, chosen for its strength, corrosion resistance, and acoustic properties. The hull itself demonstrated sophisticated hydrodynamic engineering. The bulbous bow, protruding below the waterline forward of the ship's stem, created a wave system that partially cancelled the bow wave generated by the ship's movement through water, significantly reducing resistance at high speeds. This feature, combined with the ship's fine entry, the sharp angle at which the bow cut into the water, and carefully optimized hull lines, minimized the energy required to push over 50,000 tons through the water at 35 knots. Stability, always a concern with large ships, was enhanced by the lightweight aluminum superstructure, which dramatically lowered the ship's center of gravity compared to an all-steel design. This improved stability meant the ship could be driven harder in rough weather without excessive rolling or pitching, contributing to both passenger comfort and operational safety. The ship also incorporated modern stabilization systems, anti-roll tanks that used water movement to counteract rolling motion, though the details of these systems, like so much about the United States, were not widely publicized. The fire safety systems represented another layer of engineering sophistication. The ship was divided into multiple fire zones, each with its own detection and suppression systems. Sprinkler systems covered public rooms and crew spaces. Smoke detectors, a relatively new technology in the early 1950s, provided early warning of incipient fires. Fire stations were positioned throughout the ship, each equipped with hoses, extinguishers, and protective equipment. The crew received regular fire drills, and the ship's design ensured that fire doors could seal off affected areas, containing any outbreak before it could spread. The electrical system was equally impressive. The ship generated her own electrical power through multiple diesel generators, providing redundant capacity for lighting, ventilation, refrigeration, communication systems, and the countless other electrical demands of a modern passenger liner. The electrical distribution system was designed with naval-style redundancy, ensuring that damage to one generator or distribution circuit wouldn't plunge the entire ship into darkness. Communication systems included both traditional maritime radio equipment for long-range communication with shore stations and other vessels, and internal systems for coordinating the activities of the crew. The ship's navigational equipment represented the most advanced technology available in the early 1950s, including radar systems that allowed precise navigation in fog or darkness, radio direction finding equipment, and traditional sextants and chronometers for celestial navigation. The ventilation and air conditioning systems demonstrated the scale of engineering required for a ship of this size. Every passenger space, every crew area, every machinery compartment required temperature control and fresh air. The United States incorporated powerful ventilation systems that could completely exchange the air in passenger spaces multiple times per hour, ensuring comfort even in crowded conditions. This was particularly important because the ship's high speed generated significant hull friction heating, which needed to be countered by cooling systems to maintain comfortable interior temperatures. The freshwater systems were equally sophisticated. The ship carried water ballast tanks, but potable water for drinking, cooking, and bathing had to be generated from seawater through evaporators that used waste heat from the boilers. These evaporators could produce thousands of gallons of fresh water per day, sufficient for the needs of nearly 3,000 passengers and crew. The water was then stored in tanks, treated for purity, and distributed throughout the ship through miles of piping. The sewage and waste management systems had to handle the output of a floating city. Modern treatment systems processed waste before it was discharged overboard, meeting the environmental standards of the era, modest by today's requirements, but still representing responsible engineering practice. The ship's galleys generated food waste that had to be managed, garbage that had to be stored and disposed of properly, and recyclable materials that could be separated and handled appropriately. The steering system demonstrated particular engineering elegance. Despite the ship's enormous size and high speeds, she was remarkably maneuverable. The rudder, positioned behind the propellers where it received accelerated water flow, provided powerful steering authority. The steering gear, which converted helm commands into rudder movement, used hydraulic systems that could apply tremendous force while allowing precise control. Stories from the ship's service career describe her ability to execute tight turns and respond quickly to helm commands, handling characteristics more typical of much smaller vessels. Weight distribution was critical to the ship's performance. William Francis Gibbs and his team calculated the weight and position of every major component, from the massive turbines in the engine rooms to the furniture in the passenger cabins. The ship's trim, her fore and aft balance, had to be maintained within narrow limits to achieve optimal hydrodynamic performance. As fuel was consumed during an Atlantic crossing, reducing the ship's weight by hundreds of tons, ballast systems compensated to maintain proper trim. The ship's structural strength was designed to withstand not just normal Atlantic weather, but potential military stresses. The hull was reinforced beyond civilian requirements, with frames spaced more closely than typical passenger ship practice and plating heavier than strictly necessary for commercial service. This overbuilding, mandated by the ship's potential military role, added weight and cost, but ensured that the vessel could withstand battle damage, heavy seas, and the structural stresses of sustained high-speed operation. The vibration control throughout the ship demonstrated sophisticated understanding of mechanical harmonics. High-speed machinery, particularly the turbines and propellers, generated vibration at various frequencies. If these vibrations matched the natural resonant frequencies of the hull or superstructure, destructive amplification could occur, causing structural damage or unbearable noise and discomfort for passengers. The designers used a combination of damping materials, structural reinforcement, and precise balancing of rotating machinery to minimize vibration. The result was a ship that, despite her enormous power and high speed, ran remarkably smoothly. Passengers often commented on the lack of vibration compared to other vessels. The classified aspects of the ship, her exact power output, her top speed capability, her propeller design, her military conversion features, added a layer of mystery that has persisted for decades. The Navy's insistence on secrecy meant that even technical publications and maritime historians could only speculate about certain specifications. This secrecy was not arbitrary, it reflected genuine military value. The propeller design, for example, incorporated advances in suppressing cavitation noise, making the ship quieter underwater than her size and speed would suggest. This had implications for anti-submarine warfare and naval surveillance that remained relevant throughout the Cold War. William Francis Gibbs's obsessive attention to detail pervaded every aspect of the engineering. He personally reviewed thousands of design drawings, questioned engineering decisions, and insisted on rigorous testing of critical components. His firm maintained quality control inspectors at Newport News throughout construction, ensuring that specifications were met and that workmanship met the exacting standards Gibbs demanded. This obsessiveness, while it frustrated contractors and occasionally delayed work, ultimately produced a vessel whose engineering integrity was exceptional. The ship's performance during sea trials and throughout her service career validated these engineering choices. She exceeded her contracted speed by a substantial margin. The exact amount remains classified, though knowledgeable observers have estimated she achieved speeds approaching 40 knots under ideal conditions. Her machinery proved reliable, with relatively few major breakdowns despite the stresses of high-speed operation. Her hull maintained its structural integrity throughout 17 years of hard service. Her fire safety systems were never fully tested by a major shipboard fire, but the absence of serious fire incidents aboard a passenger vessel over nearly 2 decades of operation suggests the engineering philosophy was sound. In the context of maritime history, the SS United States represented a culmination of trends that had been developing for decades. Increasing power densities, lighter construction materials, improved hydrodynamic understanding, and the application of naval design principles to civilian vessels. She was, in many respects, the final expression of these trends before technological change, specifically the rise of jet aircraft, made such extreme passenger ship engineering economically unjustifiable. No subsequent passenger liner has matched her power-to-weight ratio, her sustained speed capability, or her propulsive efficiency at high speeds. Modern cruise ships are larger, carry more passengers, and offer more elaborate amenities, but none are designed for speed. The engineering priorities have shifted entirely. Where Gibbs and his team focused on crossing the Atlantic as quickly as possible, modern cruise ship designers focus on fuel efficiency at moderate speeds, passenger entertainment capacity, and construction economy. The SS United States remains, therefore, a unique artifact, the fastest passenger ship ever built, embodying engineering principles and priorities that will almost certainly never be combined in this particular way again. She is a monument to an era when speed was valued above economy, when national prestige justified engineering extremes, and when the Atlantic crossing remained a significant journey rather than a quaint anachronism. The SS United States was conceived, designed, and built during one of the most tense periods of the Cold War, and understanding her strategic purpose is essential to understanding why such an expensive, complex vessel received government support that would have been unimaginable in purely commercial terms. In 1948, when William Francis Gibbs secured government backing for his superliner, the world seemed poised on the edge of potential catastrophe. The Berlin blockade had just begun, with the Soviet Union cutting off Western access to Berlin and the United States responding with the dramatic airlift that would continue for nearly a year. The division of Europe into Western and Soviet spheres of influence was hardening. NATO would be formed in 1949, formalizing the Western Alliance. The Soviet Union would detonate its first atomic bomb in 1949, years earlier than Western intelligence had predicted, initiating the nuclear arms race that would define the era. In this context, military planners faced a fundamental challenge: how to rapidly deploy American forces to Europe in case of Soviet aggression. The Berlin crisis had demonstrated that Western forces in Europe were insufficient to counter Soviet conventional military superiority. American military doctrine called for reinforcing Europe with troops from the United States in case of war, but this required transportation across the Atlantic, a crossing that, in the late 1940s and early 1950s, still depended almost entirely on ships. The United States Navy had developed Military Sea Transportation Service, MSTS, to coordinate sealift capacity, but the available vessels were either too slow, too old, or too small to rapidly move the number of troops that military planners believed necessary. The Navy had experimented with various designs for fast military transports, including the USS United States, a large, high-speed aircraft carrier that was cancelled in 1949 amid budgetary disputes and strategic disagreements. The cancellation of USS United States left Navy planners searching for alternative ways to achieve rapid Atlantic crossing capability. The SS United States offered an elegant solution. As a nominally civilian passenger liner, she would operate commercially in peacetime, generating revenue for United States lines while requiring only the operational subsidy typical of American-flag passenger ships. But she was designed to be converted in 48 hours into a troop transport capable of carrying 14,000 soldiers across the Atlantic at speeds that would minimize exposure to submarine attack. The primary threat NATO planners feared Soviet forces would use to interdict American reinforcement efforts. This dual-purpose capability was unprecedented in scale. Earlier American passenger liners had been designed with some consideration for military conversion. The practice dated back to the late 19th century, but none had incorporated military requirements so thoroughly into the fundamental design. The United States' high speed was directly related to submarine evasion. At 35 knots, she could outrun any submarine then in service, and even if Soviet submarines managed to position themselves in her path, her speed meant they would have minimal time to attack before she passed. The ship's compartmentalization followed naval damage control principles. If torpedoed, she was designed to remain afloat and maintain propulsion even with multiple compartments flooded. Her watertight bulkheads, her redundant propulsion systems, her naval standard electrical distribution, all of these features enhanced survivability. Gibbs had designed her to take punishment and continue operating, something no purely commercial vessel would require. The troop capacity was achievable because the ship's passenger spaces could be rapidly reconfigured. The luxurious first-class staterooms, normally accommodating 2 passengers in considerable comfort, could be fitted with standee bunks, multi-tiered sleeping arrangements, allowing each cabin to berth 8 or more soldiers. The public rooms could be converted to additional berthing. The dining rooms, normally serving elegant meals on china, could provide mass feeding for thousands of troops. The galleys were designed with military feeding capacity in mind, capable of producing simple but nutritious meals in enormous quantities. Medical facilities aboard the ship could be expanded for military use. In peacetime, the ship's hospital treated passenger illnesses and injuries. In wartime, it could serve as a casualty clearing station, providing emergency medical care for wounded soldiers being evacuated from Europe. The ship could carry medical staff, equipment, and supplies sufficient to function as a floating hospital if necessary. The ship's communication systems included military-grade equipment that could interface with naval and military command structures. Classified radio equipment, installed at government expense, allowed the ship to receive encrypted orders and maintain secure communications. The captain, though a civilian mariner in peacetime, held a reserve commission in the United States Navy and could be recalled to active duty if the ship were militarized. Beyond troop transport, the United States had other potential military applications. She could serve as a high-speed cargo transport for critical military supplies. Her large cargo holds, normally used for passenger luggage and general freight, could carry weapons, ammunition, vehicles, or other materiel. Her speed meant she could deliver urgently needed supplies to Europe far faster than conventional cargo ships. Strategically, the ship's very existence served as a deterrent. Soviet military planners, aware that the United States could rapidly transport a division of troops across the Atlantic in a matter of days, had to account for this capability in their war planning. The ship represented a visible commitment to NATO defense, a demonstration that America could and would reinforce Europe if necessary. This psychological and strategic value justified a portion of the government subsidy even apart from her direct military utility. The classification of many of the ship's specifications reflected military security concerns. The exact power output of her engines, the precise design of her propellers, the details of her military conversion features, all of these were classified to prevent potential adversaries from developing effective countermeasures. Even friendly nations were not given complete information. British and French naval attachés who toured the ship during construction were shown passenger spaces but kept away from classified areas. The government's financial support was substantial. The construction subsidy covered approximately half of the ship's $79.4 million construction cost, equivalent to roughly $390 million in government funding measured in 1952 dollars, or approximately $3.9 billion today. The operational subsidy, paid annually to United States lines to offset the higher costs of American flag operation, continued throughout the ship's commercial service. These subsidies were justified to Congress explicitly on the basis of the ship's military value. Yet despite this military purpose, the ship was never actually called into military service. During the Suez Crisis of 1956, when British and French forces intervened in Egypt and tensions rose dramatically, the United States remained in commercial service. During various Cold War confrontations, the Berlin Crisis of 1961, the Cuban Missile Crisis of 1962, she continued carrying passengers across the Atlantic. The closest she came to military service was during the build-up to the Vietnam War in the mid-1960s, when the Navy considered requisitioning her for troop transport to Southeast Asia, but ultimately decided that aircraft and other vessels were more suitable for Pacific operations. This absence of actual military employment has led some historians to question whether the ship's strategic value justified its cost. In purely utilitarian terms, the United States never fulfilled her designed military purpose. The massive investment in rapid Atlantic crossing capability was never operationally exploited. The government subsidized a very fast, very expensive passenger liner that served primarily to carry wealthy passengers and competed only marginally effectively against slower, more luxurious European rivals. However, this criticism misses the broader strategic context. Deterrence works precisely because the capability exists, not because it's used. The fact that Soviet aggression in Europe never required rapid American reinforcement doesn't mean the capability to provide such reinforcement was worthless. NATO's defensive posture, of which the United States was a small but visible part, contributed to the overall deterrent framework that prevented major war in Europe throughout the Cold War. Moreover, the ship served propaganda purposes that, in the context of Cold War competition, had genuine strategic value. When the United States broke the Atlantic speed record in 1952, the achievement received worldwide attention. It demonstrated American technological capability, industrial capacity, and national confidence. In an era when such demonstrations mattered, when the space race, the arms race, and competition in every domain was seen as reflecting the vitality of competing systems, the fastest ship in the world served national interests beyond her direct military utility. The ship's retirement from service in 1969, before the Cold War ended, occurred not because her strategic value diminished, but because the nature of strategic mobility had fundamentally changed. By the late 1960s, the United States Air Force operated fleets of C-141 and C-5 transport aircraft that could move troops and materiel to Europe in hours rather than days. Aircraft carriers, nuclear-powered submarines, and forward-deployed forces had transformed NATO's strategy. The scenario in which the United States would need to rapidly transport 14,000 troops by sea had become increasingly implausible. Yet the Cold War purpose that shaped her design remains fundamental to understanding what she was and why she existed. The SS United States was never simply a passenger liner. She was a national asset, a strategic reserve, a visible symbol of American capability, and a hedge against scenarios that mercifully never materialized. The fact that she never carried troops to Europe in wartime doesn't diminish the strategic logic that brought her into existence. It merely reflects the success of deterrence and the rapid technological changes that transformed military mobility during the ship's service life. Golden age of transatlantic ocean liner service lasted barely 15 years. As the SS United States entered service in 1952, the passenger ship industry seemed robust. Multiple companies operated scheduled services across the Atlantic. The major European lines, Cunard French Line, Holland America, Italian Line, competed vigorously for passengers. American operations, while smaller, included United States lines and the more modest services of other carriers. The future appeared to belong to newer, faster, more luxurious ships. But that future was already being written in contrails across the sky. Jet aircraft development had progressed rapidly during and after World War II. Military jets entered service in the late 1940s, demonstrating capabilities that would eventually transform civilian aviation. The British de Havilland Comet, the world's first commercial jetliner, entered service in 1952, the same year as the United States maiden voyage. Though the Comet suffered catastrophic failures that grounded the fleet and delayed the jet age by several years, the principle was proven. People could fly across the Atlantic in hours rather than spending days aboard ships. The real transformation came in 1958 with the introduction of the Boeing 707 and Douglas DC-8 on transatlantic routes. These aircraft were larger, more reliable, and more economical than earlier attempts at jet transport. Pan American World Airways inaugurated 707 service between New York and Paris in October 1958, cutting the crossing time to approximately 8 hours, less than a quarter of the time required even by the fastest ship. Other airlines quickly followed. BOAC introduced transatlantic 707 service. TUI, Air France, Lufthansa, and other carriers rapidly expanded jet operations. The impact on passenger ship traffic was immediate and devastating. In 1957, for the first time, more passengers crossed the Atlantic by air than by sea. This threshold moment marked a fundamental shift. Within 5 years, air travel had captured over 70% of the transatlantic passenger market. By the mid-1960s, ocean liners carried primarily older passengers who preferred sea travel, tourists who treated the voyage as part of their vacation experience, and a declining number of immigrants, immigration patterns having shifted toward air travel as well. The SS United States, despite her speed advantage over other ships, could not compete with aircraft on the dimension that mattered most: time. Her 3.5-day crossing, spectacular by maritime standards, was still nearly 7 times slower than jet aircraft. For business travelers, the choice was obvious. Why spend 3.5 days at sea when you could fly to Europe in 8 hours, conduct your business, and return home, all within the time a ship voyage would consume? The economics became increasingly unfavorable. Passenger loads declined. United States lines found it difficult to fill the ship's capacity, particularly outside the peak summer season. The company tried various strategies to maintain viability. Fares were adjusted to compete with air travel, but the cost structure of operating the ship, fuel, crew, maintenance, port charges, made true price competition impossible without accepting unsustainable losses. Marketing emphasized the experience of ocean travel rather than transportation efficiency, portraying the voyage as a relaxing alternative to air travel's speed and stress. This approach attracted some passengers but couldn't reverse the fundamental trend. The ship underwent a significant refurbishment in 1964 with updated interiors intended to make her more competitive. Air conditioning was improved. Public rooms were redecorated in more contemporary styles. Passenger amenities were enhanced. But these improvements, while welcome to passengers who chose the ship, did little to attract passengers away from airlines. Competition among the surviving ocean liner companies intensified as they fought for a shrinking market. Cunard introduced the Queen Elizabeth II in 1969, a ship designed from the beginning with cruise service in mind. Acknowledging that traditional point-to-point Atlantic service was no longer economically sustainable, other lines either retired their older tonnage or, like Cunard, pivoted toward cruise operations where the voyage itself was the product rather than mere transportation between ports. United States lines considered similar adaptations for the United States. The ship's design, however, made cruise conversion problematic. She consumed enormous amounts of fuel, making the economics of cruise operations questionable. Her austere interiors, while elegant, lacked the elaborate public spaces and entertainment venues that cruise passengers increasingly expected. Her high speed, her greatest asset on scheduled Atlantic service, was largely irrelevant for cruising, where slower speeds reduced fuel costs without diminishing the passenger experience. The company explored other options. Perhaps the ship could operate on different routes to the Caribbean, through the Panama Canal to the Pacific, or to South America, but each alternative faced challenges. Her deep draft limited the ports she could enter. Her passenger capacity and operational costs made her difficult to deploy profitably on shorter voyages. The military subsidy helped, but wasn't sufficient to offset losses in an industry facing structural decline. By 1968, United States Lines was losing money on the ship's operation despite government subsidies. The company faced pressure from unions whose contracts had been negotiated during more prosperous times and now represented fixed costs that couldn't be easily reduced. Insurance costs were rising. Maintenance expenses for an aging, complex vessel increased year by year. The ship needed a major overhaul, dry docking, machinery maintenance, safety upgrades that would cost millions of dollars and take the vessel out of service for months. In May 1969, United States Lines announced that the SS United States would be withdrawn from service. The company cited rising costs, declining passenger loads, and the inability to operate profitably even with government support. Labor unions protested, arguing that the ship remained viable and that the company was abandoning a national asset for short-sighted financial reasons. Maritime historians lamented the end of an era. The public, to the extent it paid attention, expressed nostalgia for the passing of traditional ocean liner service. The ship's final commercial voyage began on October 25, 1969, departing New York for Southampton and Bremerhaven. The passenger load was modest, the ship was far from full. The voyage itself was uneventful. On November 7, 1969, the SS United States arrived in New York for the last time as an operating passenger liner. She was 17 years old, still the fastest passenger ship in the world, still technically capable of the performance that had broken records nearly 2 decades earlier. But she was also obsolete, rendered economically unviable by technological change that no amount of engineering brilliance could overcome. The ship was laid up at Newport News, Virginia, where she had been built. United States Lines hoped the withdrawal would be temporary, that solutions could be found to return her to service. Various proposals were considered: government operation, private purchase, conversion to different purposes. But 1969 became 1970, and 1970 became 1971, and the ship remained idle, accumulating rust and deterioration, her future uncertain and her prospects dimming with each passing year. The end of the SS United States commercial career marked more than the retirement of a single ship. It represented the conclusion of the era when ocean liners served as primary transportation across the Atlantic, an era that had lasted over a century, from the first steamship crossings in the 1830s through to the late 1960s. Ships had connected continents, carried millions of immigrants to new lives, transporting soldiers to war, and served as stages where the dramas of industrial society played out. Now, with breathtaking speed, that era had ended, and the great ships that had defined it faced uncertain futures. The irony was profound. The SS United States had been built to be the fastest, the best, the most technologically advanced passenger ship in the world. She had achieved those goals completely, and none of it mattered when confronted with a different technology that made the very concept of fast ocean liners irrelevant. Speed, the quality Gibbs had prized above all else, couldn't compete with flight. Engineering excellence couldn't overcome economic reality. National pride couldn't substitute for commercial viability. The ship that had won the Atlantic would spend the next half-century searching for a purpose, her fate becoming a cautionary tale about the challenges of preserving technological monuments when their original function has been superseded by progress. The SS United States spent nearly a quarter-century laid up at various locations, deteriorating slowly, while a succession of owners, investors, and dreamers proposed schemes to restore her to service. This long twilight, from 1969 through the early 1990s, saw the ship transformed from a recently retired liner into an increasingly corroded artifact, her condition worsening with each year of inactivity. Initially moored at Newport News, the ship remained the property of United States Lines, which continued to maintain minimal staffing to prevent vandalism and catastrophic deterioration. But the company's financial situation was precarious. The maritime industry faced challenges across all sectors. Containerization was transforming cargo shipping, government subsidies were being questioned, and United States Lines struggled to adapt. The company couldn't afford to maintain an idle passenger liner indefinitely, particularly one as large and expensive as the United States. In 1973, the ship was sold to Seattle real estate developer Richard Hadley for $5 million, a fraction of her construction cost, but more than scrap value. Hadley proposed converting her into a combination hotel, museum, and convention center to be permanently moored at various locations. He explored docking the ship in Seattle, San Francisco, and other West Coast ports, but the economics never worked. The conversion costs were prohibitive, the regulatory hurdles significant, and the business case questionable. After several years of failed negotiations and abandoned plans, Hadley's ownership ended without the ship having moved or been modified. The vessel was sold again in 1978 to the United States Cruises Corporation, which announced plans to return her to passenger service as a cruise ship. This seemed more promising than Hadley's static hotel concept. The ship was, after all, designed to move. The new owners commissioned engineering studies to assess the feasibility of refurbishment and modernization. The studies revealed daunting challenges. The ship's boilers, idle for nearly a decade, would require complete refurbishment or replacement. Asbestos insulation, used extensively when the ship was built, would need removal under increasingly strict environmental regulations. Modern safety standards required upgrades to fire suppression, life-saving equipment, and accessibility features. The interiors, while structurally sound, were dated and would need extensive renovation to meet contemporary cruise passenger expectations. The estimated costs escalated from initial projections of $30 million to over $60 million, then higher. United States Cruises couldn't raise the capital. The company defaulted on payments, and the ship was foreclosed upon by its creditors in 1984. She was towed from Virginia to Norfolk, where she would remain, largely forgotten, for nearly 8 more years. During these years of idleness, the ship suffered inevitable damage. Though her aluminum superstructure resisted corrosion better than steel would have, moisture intrusion caused problems throughout. Her steel hull, below the waterline, developed rust in numerous locations. Piping systems, drained when she was laid up, corroded internally. Electrical systems deteriorated. Interior furnishings, exposed to humidity and temperature fluctuations, degraded. The ship wasn't being actively maintained. She was merely being prevented from sinking or catching fire, and sometimes barely that. Vandalism and theft compounded the problems. Despite security efforts, individuals managed to board the ship and strip valuable materials. Brass fittings, copper pipes, aluminum fixtures, anything that could be removed and sold as scrap was at risk. The famous Steinway pianos disappeared. Artworks were taken. Even structural elements were damaged by salvagers looking for valuable metals. Each intrusion caused additional deterioration beyond the immediate theft. Maritime museums occasionally expressed interest in acquiring the ship, but none could manage the financial burden. The ship was simply too large, too expensive to maintain, and too specialized to fit into typical museum operations. Floating museums require continuous upkeep. Even moored permanently, ships need hull maintenance, deck work, painting, and systems preservation. The United States would require all of this at a scale that would overwhelm most museum budgets. The U.S. Maritime Administration, which had subsidized the ship's construction and operation, was approached about taking custody but declined. The government had no mission requirement for the vessel and no budget for her preservation. The Navy, which had classified so many of her specifications, had long since moved on to nuclear-powered vessels and air transport for personnel movement. The Cold War strategic rationale that had justified her construction was no longer compelling. In 1992, the ship faced her most serious threat yet: sale for scrapping. Turkish scrapping interests made an offer to purchase the vessel, tow her to Turkey, and dismantle her for scrap metal. Given the ship's condition and the absence of viable alternatives, this seemed likely to proceed. The great ship that had broken transatlantic records 4 decades earlier appeared destined for the cutting torches. At this critical juncture, a new actor entered the story. Marmara Marine, a Turkish-American maritime investment group, purchased the ship not for scrapping, but with the intention of converting her into a cruise ship. To facilitate conversion work, the ship was towed across the Atlantic, an ironic echo of her record-breaking crossings, though now she was unpowered, pulled by ocean-going tugs at a fraction of her former speed. She arrived in Turkey, where she was moored while Marmara Marine developed conversion plans. But once again, economic reality intervened. The costs of conversion in Turkey, while lower than in American yards, still proved prohibitive given the ship's condition and the investments required. Marine couldn't secure financing for the project. Rather than abandon the ship in Turkey, where she might well have been scrapped when port fees accumulated, the company arranged to have her towed back across the Atlantic. In 1996, the SS United States arrived in Philadelphia, where she was moored at Pier 82, a location that would become her home for decades. Ukrainian-American developer Edward Cantor purchased the ship from Marine, announcing ambitious plans to convert her into a hotel and entertainment complex on the Delaware River waterfront. Cantor commissioned yet another round of engineering studies, which confirmed what previous studies had found. Restoration would be extraordinarily expensive. The asbestos removal alone would cost tens of millions of dollars. Modernizing her power plant, refurbishing passenger spaces, and bringing the ship into compliance with contemporary regulations for a permanently moored structure would require investments approaching the cost of building a new hotel. Cantor's plans, like so many before, failed to materialize. The financing couldn't be arranged, regulatory approvals proved elusive, and public support, while emotionally positive, didn't translate into the financial backing necessary for such a massive project. The ship remained at Pier 82, her condition continuing to deteriorate, her future no more certain than it had been a decade earlier. In 2003, Norwegian Cruise Line briefly took ownership, considering conversion to a cruise ship for contemporary service. NCL had successfully operated the SS Norway, the former France, as a cruise ship for years, demonstrating that classic ocean liners could find second lives. But the Norway had been retired in 1974, not 1969, and had been maintained to higher standards during her layup period. The United States, by 2003, was in substantially worse condition. NCL concluded the conversion wasn't economically feasible and relinquished ownership. The ship returned to Cantor's organization, which continued paying docking fees to keep her in Philadelphia while seeking solutions. But by the mid-2000s, even this minimal stewardship became financially strained. The ship had been idle for nearly 40 years. An entire generation had grown up with no memory of her in service. To most Americans, she was an unknown artifact, if they were aware of her at all. The broader maritime heritage community recognized her significance, but awareness didn't translate into the resources needed for preservation. The deterioration accelerated. By 2010, the ship was in grave condition. Her hull was extensively corroded, requiring continuous pumping to prevent flooding. Her superstructure, while still largely intact due to aluminum's corrosion resistance, showed damage from decades of weather exposure. Interior spaces were filled with mold, debris, and evidence of water infiltration. The mechanical spaces, once pristine engineered environments, were corroded and damaged beyond any reasonable hope of restoration to operating condition. Environmental concerns added another layer of complexity. The ship contained not just asbestos, but also other hazardous materials typical of 1950s construction: lead paint, PCBs in electrical equipment, and various toxic substances. Environmental regulations required these materials to be handled as hazardous waste, dramatically increasing any remediation or scrapping costs. The ship couldn't simply be demolished in place. She would need to be properly abated, adding millions to any disposal scenario. Yet even in this deteriorated state, the United States remained structurally impressive. Her hull, despite corrosion, retained its fundamental form. Her superstructure, though weathered, still displayed the graceful lines Gibbs had designed. Her funnels, though unpainted and stained, remained distinctive landmarks visible from Philadelphia's waterfront. She was a ghost of her former glory, but still recognizably the ship that had conquered the Atlantic. The question facing maritime historians, preservationists, and anyone who cared about the ship was increasingly urgent. Could she be saved? And if so, how? The decades of deterioration had pushed her ever closer to the point where preservation would become physically impossible, where the structure would be so compromised that restoration, even with unlimited funds, couldn't succeed. Time was not on the ship's side, and each year of inaction made eventual preservation less likely. The formation of the SS United States Conservancy in 2009 marked a turning point in efforts to preserve the ship. This non-profit organization, led by Susan Gibbs, granddaughter of William Francis Gibbs, brought renewed energy, professionalism, and public attention to the preservation cause. For the first time since the ship's retirement, a dedicated organization existed solely to ensure her survival and eventual restoration. The Conservancy's first challenge was immediate. The ship's owner, Norwegian Cruise Line Heritage Company, successor to Edward Cantor's interests, could no longer afford the $60,000 monthly docking fees at Pier 82. Without resolution, the ship faced eviction from her berth, which would likely lead to scrapping. No one would pay to tow her to another location without a clear plan for her future. The Conservancy launched an emergency fundraising campaign, seeking both to assist with immediate costs and to develop a longer-term preservation strategy. The campaign succeeded in raising public awareness. Media coverage highlighted the ship's history and significance. Maritime historians wrote articles explaining her technological importance and her place in American cultural memory. Naval architects and engineers provided testimonials about her design innovations. Former passengers and crew members shared memories. The ship, forgotten by most Americans for decades, suddenly became the subject of renewed interest and even affection. In 2011, the Conservancy took a major step. It purchased the ship from NCL Heritage for $3 million. This transaction, funded by donations and a significant contribution from philanthropist H.F. Jerry Lenfist, transferred ownership to the organization explicitly dedicated to her preservation. For the first time since 1969, the ship's owner had preservation rather than commercial operation as its primary goal. Ownership brought responsibilities. The Conservancy assumed the docking fees, insurance costs, security expenses, and other carrying costs that amounted to nearly $800,000 annually. These ongoing expenses required continuous fundraising. The organization needed not just capital for eventual restoration, but operational income to prevent the ship from being evicted or scrapped due to accumulated debts. The Conservancy commissioned engineering assessments to determine the ship's structural condition and develop realistic preservation scenarios. The findings were sobering. The hull was extensively corroded, particularly below the waterline where steel was exposed to decades of immersion. Structural frames showed metal loss in numerous locations. Some deck areas were weakened by corrosion. The superstructure was in better condition due to aluminum's corrosion resistance, but damage was still evident from weather exposure and material degradation. Crucially, the engineers concluded that despite this deterioration, the ship's structure remained salvageable. With proper intervention, steel replacement, structural reinforcement, environmental abatement, the hull could be restored to safe condition. The superstructure could be preserved and refurbished. The ship could, in theory, be converted to a viable purpose: a hotel and museum complex, an event venue, or potentially even return to limited seagoing service for special occasions. But all of this would require massive investment, sophisticated engineering, and sustained commitment over many years. The Conservancy developed a multi-phase preservation plan. Phase 1 focused on stabilization, addressing immediate structural concerns, removing environmental hazards like asbestos, and halting deterioration. Phase 2 would involve actual restoration, repairing or replacing damaged structure, refurbishing or replicating interior spaces, and creating a viable reuse plan. Phase 3 would be redevelopment, converting the ship to her new purpose, whether as a permanently moored attraction or potentially as a partially operational vessel for short cruises or special events. Environmental remediation became an urgent priority. The ship contained an estimated 800 tons of asbestos insulation distributed throughout machinery spaces, interior compartments, and structural areas. Environmental regulations required this material to be professionally removed and disposed of as hazardous waste. The Conservancy undertook this work in phases between 2013 and 2016, removing asbestos from accessible areas at a cost exceeding $7 million. While not all asbestos could be removed, without more extensive dismantling. The effort significantly reduced the environmental liability and demonstrated that the ship could meet modern regulatory standards. Finding a permanent home for the ship became a central challenge. Philadelphia's Pier 82 was expensive and not ideal for public access. The Conservancy explored alternative locations where the ship could be permanently moored, restored, and opened to the public. Various cities expressed interest: New York, where the ship had been homeported during her service years; Newport News, where she was built; Norfolk, where she had spent years laid up; Miami, seeking to establish a maritime museum, and others. Each potential location presented advantages and challenges. New York offered maximum visibility and tourism traffic, but berthing costs in Manhattan were prohibitively expensive. Newport News had historical connections and maritime infrastructure, but less tourism traffic. Miami had cruise industry connections and year-round visitors, but no historical connection to the ship. The Conservancy evaluated proposals, seeking the combination of affordable long-term berthing, public access potential, and local government support that would make restoration economically viable. In 2015, the situation became critical again. The Philadelphia pier operator, Penn Warehousing, needed the berth for commercial operations and gave the Conservancy notice to vacate. Without a new location secured, the ship faced potential scrapping. No one would accept a vessel this large and expensive without a concrete plan. The Conservancy launched another emergency campaign, this time seeking to negotiate a temporary extension while a permanent solution could be developed. Crystal Cruises, a luxury cruise line, emerged as a potential savior. The company announced in 2016 that it would purchase the ship from the Conservancy for approximately $60 million and undertake a comprehensive $700 million restoration, converting her into an ultra-luxury cruise ship serving global routes. This proposal seemed ideal: a well-financed company with cruise industry expertise committing to preserve the ship while returning her to seagoing service. The Conservancy signed a purchase agreement, and Crystal began preliminary engineering studies. For over a year, the possibility seemed real. Crystal's engineers surveyed the ship, developed restoration concepts, and discussed timeline and budget. The vision was compelling: preserve the ship's exterior character and historic public spaces while modernizing machinery, installing contemporary luxury accommodations, and creating a vessel that could operate profitably in the 21st century cruise market. The ship would be towed to a shipyard, likely in Europe or Asia, where restoration expertise and costs were more favorable, and undergo a multi-year reconstruction. But in 2017, Crystal Cruises' parent company faced financial difficulties. The cruise line, which had been operating successfully, encountered problems stemming from its ownership structure. In 2018, Crystal formally withdrew from the purchase agreement, citing inability to secure financing for the restoration at terms that made business sense. The Conservancy retained ownership, and the search for solutions resumed. This cycle of hope and disappointment had repeated multiple times over decades. Each proposal generated enthusiasm, media attention, and expressions of support, only to collapse when confronted with the harsh economic realities of restoring a deteriorating 70-year-old ship. The pattern was dispiriting, but also revealed a fundamental truth: preserving the SS United States required not just good intentions or even significant capital, but a viable business model that could sustain the investment over time. RXR Realty, a major real estate developer, began exploring a new approach in 2019, permanently mooring the ship as part of a mixed-use waterfront development. Rather than returning her to seagoing service or creating a standalone museum, this concept integrated the ship into a broader real estate project where hotel, office, residential, and entertainment uses could cross-subsidize the ship's preservation and operation. Several locations were evaluated, with New York's Brooklyn waterfront emerging as a leading candidate. The COVID-19 pandemic in 2020 disrupted these discussions as it disrupted so much else. Tourism collapsed, cruise lines faced unprecedented crises, and real estate development slowed. The Conservancy focused on basic stewardship, maintaining security and managing the ship's deteriorating condition with extremely limited resources. Donations decreased as economic uncertainty spread. The organization implemented emergency cost reductions while seeking to maintain enough stability to survive until conditions improved. In 2021, new urgency emerged. Pen warehousing, which had extended the ship's berth repeatedly over the years, indicated that this time the deadline for departure was firm. The Conservancy needed to secure a new berth or face the real possibility that the ship would need to be scrapped. In this context, the partnership with Okaloosa County, Florida, developed. The county, seeking to create a major tourist attraction, offered to create a berth and provide support for the ship's restoration as an artificial reef, museum ship, or mixed-use attraction on Florida's Gulf Coast. This proposal generated significant controversy within the preservation community. Moving the ship to Florida would separate her from the northeastern locations associated with her history. Converting her to an artificial reef would mean intentional sinking, destroying the very artifact preservationists sought to save, even if it created marine habitat and diving opportunities. The Conservancy emphasized that the Florida Partnership was not about creating a reef, but about securing a location where restoration could proceed, though the reef option remained as a last resort if restoration proved truly impossible. Throughout 2022 and 2023, negotiations continued while the ship's condition deteriorated further. Engineering surveys indicated that while the structure remained salvageable, the window for preservation was narrowing. Corrosion was accelerating in some areas. The longer the ship sat idle, the more expensive any eventual restoration would become. The Conservancy worked desperately to finalize arrangements with Okaloosa County, while also keeping channels open with other potential partners. In late 2023, the situation reached another crisis point. Legal and regulatory complications delayed the Florida move. Docking fees in Philadelphia continued accumulating. The ship's condition continued declining. Media coverage focused increasingly on whether the fastest ocean liner ever built would be lost forever, not through lack of historical significance or public interest, but through the prosaic reality of insufficient funds to overcome entropy and time. As of 2024, the SS United States remains at her Philadelphia berth, her future still uncertain. The Conservancy continues its work, maintaining the ship, seeking partners, exploring options, and refusing to concede defeat. But the organization, its supporters, and everyone who cares about the ship understands that time is running out. Each year of delay makes preservation more difficult and more expensive. Each winter of weather exposure causes additional damage. Each accumulation of docking fees and carrying costs depletes resources that could otherwise fund restoration. The battle for preservation has become a race against time, economics, and the second law of thermodynamics. The question is no longer whether the SS United States could theoretically be preserved. Engineering studies confirm that remains possible. The question is whether the financial resources, political will, and organizational capacity can be marshaled before the ship deteriorates beyond the point where preservation is physically or economically feasible. The preservationists have not given up, but they are fighting against powerful forces: the enormous costs of maritime preservation, the complexity of historic ship restoration, the difficulty of developing viable business models for preserved vessels, and the simple physical reality that metal corrodes, structures weaken, and time destroys what human effort does not actively maintain. The SS United States, whether she is ultimately preserved or lost, has already secured a permanent place in maritime history and American cultural memory. Her legacy extends far beyond her 17 years of commercial service, embodying lessons about engineering ambition, national purpose, technological change, and the challenges of preserving industrial heritage. As a technological achievement, the ship represents the pinnacle of a particular approach to passenger vessel design. William Francis Gibbs created a ship that optimized for speed, safety, and structural efficiency in ways that have never been surpassed. Her power-to-weight ratio, her sustained speed capability, her innovations in aluminum construction and fire safety. These achievements influenced subsequent ship design even as the economic rationale for such extreme passenger ship engineering disappeared. Naval architects studying the United States have identified numerous innovations that were subsequently adopted in other vessels. Her extensive use of aluminum in superstructure construction became standard practice for ships where weight reduction was important. Her compartmentalization and damage control features influenced both civilian and military vessel design. Her propeller design, though still classified in detail, contributed to broader understanding of high-speed marine propulsion. The ship was, in effect, a floating laboratory that pushed multiple technologies to their limits and demonstrated what was possible when engineering excellence took priority over cost constraints. The ship's speed record, still unbroken after more than 7 decades, has taken on almost mythological status. In an era when records in nearly every field are constantly challenged and surpassed, the fact that no subsequent passenger ship has even approached the United States transatlantic crossing times seems almost impossible. Modern cruise ships are vastly larger but dramatically slower, designed for fuel efficiency rather than speed. The record stands not because later engineers couldn't design faster ships, but because the economic and operational rationales for extreme passenger ship speed no longer exist. This record serves as a tangible reminder of a different era, when speed was valued differently, when national prestige was bound up in technological demonstrations, and when the Atlantic crossing remained significant enough to justify building the fastest possible ship. The United States is, in this sense, a monument to priorities that seem almost alien in contemporary transportation economics, where efficiency, cost per passenger mile, and environmental impact matter far more than absolute speed. As a Cold War artifact, the ship illuminates the intersection of military strategy and civilian infrastructure during a period of ideological competition. The dual-purpose design, luxury liner and troop transport, commercial operation and strategic reserve, reflected a particular moment in American defense planning when rapid seaborne reinforcement of Europe seemed essential. The fact that this capability was never used doesn't diminish its historical significance. Rather, it demonstrates how deterrence and capability interact in military strategy. The ship was designed for a worst-case scenario that mercifully never occurred. The classification that surrounded so many of the ship's features during her construction and early service has contributed to her mystique. Even today, exact specifications for her power output, her top speed under ideal conditions, and certain design details remain officially classified. This secrecy, necessary in the context of 1950s security concerns, has created an aura of mystery around the ship that persists in maritime history circles. Enthusiasts debate her true capabilities, historians petition for declassification of documents, and the ship occupies a unique space as a partially known artifact whose full specifications may never be publicly revealed. As a business venture, the ship illustrates the tension between engineering excellence and commercial viability. Gibbs designed a masterpiece, but one that was extraordinarily expensive to operate. United States Lines operated a ship that captured prestige and media attention, but struggled to generate profits even with government subsidies. The company's experience with the United States contributed to broader understanding that technological superiority doesn't automatically translate into commercial success, a lesson relevant far beyond maritime operations. The ship's rapid obsolescence in the face of jet aircraft demonstrates how technological change can make even the most advanced systems irrelevant. The United States was cutting edge, the fastest ship ever built, incorporating the most advanced technologies of her era. None of this mattered when confronted with aircraft that could cross the Atlantic in a quarter of the time. This pattern, excellence in a technology made irrelevant by a different technology, recurs throughout industrial history, but few examples are as dramatic as the passenger liner industry's collapse in the face of commercial aviation. The long struggle to preserve the ship raises profound questions about how societies value and maintain their industrial heritage. Historic preservation has traditionally focused on buildings, particularly those with architectural or cultural significance. Ships present unique challenges. They deteriorate more rapidly than land-based structures. They require specialized maintenance knowledge. Their sheer size makes preservation expensive, and their original functions are often obsolete. The SS United States embodies all these challenges at extreme scale. The repeated cycles of proposed preservation schemes, each generating hope before collapsing due to economics, reflect broader difficulties in historic ship preservation worldwide. Successful examples exist: the Queen Mary in Long Beach, California, the SS Rotterdam in the Netherlands, various military vessels preserved as museums. But for every success, multiple ships have been lost to scrapping because preservation proved financially or logistically impossible. The United States' size, complexity, and deteriorated condition place her among the most challenging preservation cases in maritime history. Yet the persistence of preservation efforts, even in the face of repeated setbacks, demonstrates that the ship retains cultural resonance. The Conservancy's work, supported by thousands of individual donors and passionate advocates, reflects a belief that some artifacts are worth saving despite enormous challenges. This belief stems partly from the ship's objective historical significance, but also from something less tangible: the sense that the United States represents an era of American capability and ambition that should not be forgotten, that her loss would represent the loss of a tangible connection to that era. For the generation that traveled aboard her, the ship evokes personal memories of Atlantic crossings, of departure scenes on New York piers, of shipboard life that has now completely vanished. For those who built her at Newport News, she represents the craftsmanship and skill of American shipbuilding at its peak. For naval architects and marine engineers, she represents the limits of what was possible in passenger ship design. For Americans generally, she represents a moment when American industrial and technological capability was unquestioned, when the nation could build the biggest, the fastest, the best, and succeed spectacularly. The ship also embodies a certain melancholy, the sadness of lost potential, of magnificent technology rendered obsolete, of careful preservation becoming an uphill battle against time and economics. There is tragedy in the image of the fastest ship ever built sitting immobile at a Philadelphia pier, deteriorating slowly, her future uncertain while her past glories fade into history. This tragedy resonates because it seems to reflect broader patterns of American industrial decline, of magnificent achievements followed by failure to maintain them, of excellence in creation but difficulty in stewardship. If the ship is ultimately preserved, restored to static display as a museum, converted to new purpose, or even returned to some limited operational capacity, she will serve as a powerful educational tool. Visitors could experience the scale and power of a technology that once seemed cutting-edge. They could learn about the Cold War context that shaped her creation. They could appreciate the engineering sophistication that made her the fastest. They could reflect on the interplay of technology, economics, and social change that made her obsolete. The ship could become, in effect, a three-dimensional history lesson about mid-20th century American technology and society. If preservation fails and the ship is ultimately scrapped or lost, she will join the long list of historically significant vessels that no longer exist except in photographs, documents, and memory. This would be a genuine loss to maritime heritage, but it would also provide its own lessons about the difficulties of preservation, the economics of maintaining large industrial artifacts, and the challenges of valuing historical significance against present-day costs. Either way, the story of the SS United States, from conception through triumph to decline and preservation struggle, will remain significant. She represents a particular moment in technological history, a specific approach to engineering challenges, and a window into American society during the early Cold War. Her legacy is secure even if her physical structure is not. The ship reminds us that excellence in engineering doesn't guarantee commercial success, that technological superiority can be suddenly rendered obsolete, that national pride and strategic necessity can drive creation of magnificent achievements, and that preserving the past's artifacts requires sustained commitment and resources that societies often struggle to provide. These lessons extend far beyond maritime history, touching on fundamental questions about how we value achievement, how we respond to technological change, and how we remember our industrial and technological heritage. The SS United States is ultimately more than a ship. She is a symbol of an era, a testament to engineering ambition, a Cold War artifact, a preservation challenge, and a reminder of both the heights of human technological achievement and the difficulties of maintaining such achievements once their immediate utility has passed. Whether she survives physically or only in historical memory, her significance, technical, cultural, and historical, remains undeniable. She was, quite simply, the fastest ship ever built, and her story embodies the triumphs and tribulations of the American century itself. As this documentary concludes, the SS United States remains in Philadelphia, her fate still undecided. She sits at Pier 82, her distinctive silhouette visible from the waterfront, a massive presence that draws the attention of those who pass by even if they don't know her history or significance. The ship has now spent more than 5 decades in layup, far longer than her 17 years of active service. She has become, in a sense, more famous for her preservation struggle than for her achievements at sea, though those achievements remain the reason anyone cares about preserving her. The latest developments continue the pattern of hope and uncertainty that has characterized her story since 1969. Negotiations with Okaloosa County continue. Other potential partners emerge periodically, express interest, conduct studies, and sometimes fade away when confronted with the scale of the challenge. The Conservancy works tirelessly, raising funds, managing the ship's deterioration, seeking solutions, and maintaining the belief that preservation remains possible. Engineering reports confirm that the ship's structure, despite decades of deterioration, could still be salvaged with appropriate intervention. But those same reports document accelerating corrosion, increasing fragility, and a narrowing window for action. The ship is not yet beyond saving, but she is approaching that point. Without major preservation work within the next few years, the damage may become so extensive that restoration becomes physically impossible, regardless of funding. The preservation battle has become emblematic of broader challenges in maintaining industrial heritage. The United States is not alone in facing an uncertain future. Other historic ships, historic buildings, historic machinery face similar struggles. The pattern is familiar: initial creation as functional object, period of use and obsolescence, transition to historic artifact, struggle to fund preservation, gradual deterioration while solutions are sought, and finally either successful preservation or loss. The SS United States is currently suspended in the penultimate stage, with the final outcome still undetermined. Those who advocate for her preservation argue that her historical significance, as the fastest passenger ship ever built, as a Cold War artifact, as a technological achievement, justifies extraordinary efforts to save her. They point to successful examples of preserved ships that now serve as museums and tourist attractions, generating economic activity and educational value. They emphasize that once the ship is lost, it can never be recovered. Scrapping is irreversible. Those who question whether preservation is feasible or worthwhile point to the enormous costs involved, the absence of a clear business model that would sustain the ship after initial restoration, and the opportunity costs, the other historical or social projects that could be funded with the hundreds of millions of dollars required for comprehensive restoration. They suggest that extensive documentation, preservation of artifacts and components, and digital modeling might capture the ship's historical significance without requiring preservation of the entire physical structure. Both perspectives have merit. The debate reflects genuine tensions in how societies allocate resources, value history, and make decisions about preservation priorities. There is no obviously correct answer, only choices with different consequences and trade-offs. What remains clear is that time is running out. The ship that broke records in 1952, that carried thousands of passengers across the Atlantic, that represented American technological confidence and Cold War strategic planning, that embodied William Francis Gibbs's life work and obsessive engineering excellence. That ship is deteriorating at a Philadelphia pier while people of goodwill struggle to save her. The final chapter of her story has not yet been written. Perhaps it will involve successful restoration and a new life as a museum or attraction. Perhaps it will involve creative reuse that preserves key elements while adapting the structure to contemporary needs. Perhaps it will involve the heartbreaking decision that preservation is no longer feasible and that the ship must be responsibly recycled, her materials reclaimed even as her form is lost. Whatever happens, the SS United States will remain significant in maritime history. She was the fastest, and no one has surpassed her. She represented a particular moment in American history when building the best seemed not only possible but necessary. She demonstrated engineering capabilities that still impress professionals decades later. She connected the age of ocean liner transportation to the jet age that superseded it. She embodied the dreams of her designer, the pride of her builders, the memories of those who traveled aboard her, and the persistence of those who fight to preserve her. The fastest ship ever built sits quietly now, rust spreading across her steel hull, her aluminum superstructure weathered but still recognizable, her funnels silent monuments to the power that once drove her across the Atlantic faster than anyone thought possible. She waits, suspended between past glory and an unknown future, a testament to what American engineering could achieve and a challenge to whether American society can find the will and resources to preserve that achievement for future generations. Her story, triumph and tragedy intertwined, continues. The ending remains to be written.